Hello students, welcome to CET online classes. In the last class we started the discussion based on thermodynamics. So we'll see with the continuation of that. I think in the last class we left with the 12th problem. Okay, so we'll see the 12th problem. A sample of ideal gas is heated at constant pressure. So constant pressure andre the gamma whatever they've given, it is nothing but Cp. So you have to please remember that. Okay. So they given Cp is equal to 1.4. Okay. If 100 joule of heat is supplied to the gas. Okay. 100 joule of heat is means dq is equal to 100 joules is supplied to the gas. The work done by the gas is ಅಂತ ಕೇಳಿದ್ದಾರೆ. Okay, so you have the formula dq is equal to ncp dt. Okay, then du is equal to ncv dt. Okay, so finally you can write dw is equal to dq minus du. So ಅದನ್ನ substitute ಮಾಡಿದಾಗ you can take n and dt is common. So cp minus cv, correct? Fine. So the work done, so I can write this as, divide the whole term by, you can write this as dw by dq is equal to, ಹೌದಾ? ಸೊ ಏನಿದು n dt cp minus cv whole divided by n dt cp. ಸೊ ಇದು ಮತ್ತೆ ಇದು ಕ್ಯಾನ್ಸಲ್. ಸೊ ಆಗಿದು cp by cp is 1 minus cv divided by cp. So dw divided by dq is 100. So you can write dw is equal to 1 minus 1 divided by 1.4. Okay, so ಇದು 1.4 minus into 100 ಇದು 1.4 minus 1 divided by 1.4 into 100. So again ಆಗ್ತದೆ 0.4 divided by 1.4 into 100. So finally you can write it as 4 by 14 into 100. 2s are 7s are, so 200 by 7 is 28.57 joules. Option A, that is option 1. I hope you are clear with this. Okay, so next we have to start from the 16th problem. Okay. The 16th problem you can say here, the work of 146 kilojoule is performed in order to compress 1 kilomole of gas adiabatically, and in this process the temperature of the gas increases by 7 degrees Celsius. Okay, so the gas is, so you have to check with the whether it is atomic or diatomic ಅಂತ ಚೆಕ್ ಮಾಡ್ತೀಯ. Okay, so you have to remember atomic diatomic ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂಸ್ಗಳನ್ನ ನೀಟಾಗಿ ನೀವು ಜ್ಞಾಪಕ ಇಟ್ಕೊಬೇಕು. Okay, so if I want to remember that values, okay, TG ಅಲ್ಲಿ you would have seen thermodynamics ಅಲ್ಲಿನೇ you would have seen that one completely, right? Okay, so based on that we are going to have the discussion. We have the formula in an adiabatic process. W is equal to nr T1 minus T2 divided by 1 minus gamma. Try ಮಾಡಿ 1 kilo ಅಂದರೆ n ಎಷ್ಟು 1000, r ಬಂದು 8.3 into change in ಅಂದರೆ 7 divided by 1 minus gamma. So work done ತಗೊಂಡಾಗ it is minus adiabatic process ಆಗಿರೋದ್ರಿಂದ minus into 10 to the power 3. So 10 to the power 3 ಮತ್ತು 1000 ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು. ಸೊ ಈ ನೆಗೆಟಿವ್ ಸೈನ್ ಹಂಗೆ ಇಟ್ಕೊಂಡ್ರೆ ಆಯಿತಾ, ಮೈನಸ್ ಆಫ್ ಮೈನಸ್ ಪ್ಲಸ್ ಗಾಮಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 8.3 into 7 divided by 146. ಸೊ ಅವಾಗ ಏನಾಯ್ತಿದು ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿ ಟ್ರೈ ಮಾಡಿ ಬೇಗ. So I think here you'll be getting it as 0.39. So gamma is equal to plus 1 ಅಂದರೆ 1.39. So 1.39 ಅಂದರೆ so approximately it is 2 ಬರುತ್ತಲ್ವಾ. So it is diatomic. Okay, next up. The freezer in a refrigerator is located at the top section so that you can say the entire chamber of the refrigerator is cooled quickly due to convection. Why? Because the temperature on the lowest side of the refrigerator is more than upper side. The hot gases rise due to convection, and things placed there get cooled quickly. So the right option is 1. So clear ಆಯ್ತು ಅನ್ಸುತ್ತೆ. I'll tell the reason once again. Because the temperature on lower side of the refrigerator is more than upper side, the hot gases rise up due to convection, and things placed there get cooled quickly. Okay. An ideal Carnot engine whose efficiency is 40% receives heat at 500 Kelvin. If its efficiency were 50%, then intake temperature for some exhausted temperature would be. Okay, you have the formula. So you have the formula. It is eta is equal to 1 minus T2 by T1. Okay, I can interchange this and I can write it as T2 by T1 is equal to 1 minus eta. So it is 1 minus 40 by 100 is nothing but 100 minus is 60. 3 by 5. So T1 ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ವಾ, ಸೊ T2 is equal to 3 by 5 into T1 ಎಷ್ಟು 500, ones are 100, so T2 is equal to 300 Kelvin ಆಯ್ತು. ಬಟ್ ಈಗ ನಂಗೆ T1 ಕಂಡುಹಿಡಿಬೇಕು, ರೈಟ್? ಸೇಮ್ ಅದೇ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡು, ಬಟ್ 50% ಕೊಟ್ಟಿರೋದು ಈಗ 40% ಅಂತ ಇರೋದು ಈಗ 50% ಆಗುತ್ತೆ ಎಫಿಷಿಯನ್ಸಿ. So again same formula, T2 by T1 is equal to 1 minus 50 divided by 100. So again 50 by 100 ಬರುತ್ತೆ. 1 1 1s are 2s are. So ಈಗ T1 ಬೇಕಲ್ವಾ, so T1 is equal to T2 ಎಷ್ಟು 300 divided by 1 by 2, so it is 600 Kelvin. So option 4. ಅರ್ಥ ಆಯ್ತಲ್ಲ, ರೈಟ್? So next problem, a thermodynamic system is taken through the cyclic PQRSP. Okay, make it fast. Okay, so ಈಗ ಇಲ್ಲಿ ನೋಡಿದಾಗ thermodynamic, so as you can see here the cycle, so the work done is nothing but area of loop, right? Area of loop and it is in rectangular, so you can write SP into PQ. So SP ತಗೊಂಡಾಗ it is 200 minus 100, so it is 100 into 10 to the power 3, ಯಾಕಂದ್ರೆ ಕಿಲೋ ಅಂತ ಇದೆ, into, so PQ ಅಂದ್ರೆ 300 minus 100 is 200, so CC ಅಂತ ಇದೆ, it is nothing but 10 to the power minus 6, so ಇದು 10 to the power 5 ಬರುತ್ತೆ, into 200 divided by 10 to the power 6. 6 ಮತ್ತು 5 ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು, ಮತ್ತೆ 0 and 0 ಕ್ಯಾನ್ಸಲ್ ಆಯಿತು, ಸೊ ಇಟ್ ವಿಲ್ ಬಿ 20. ಈಗ ನೋಡಿ ಗ್ರಾಫು, ಸಿನ್ಸ್ ಇಟ್ ಈಸ್ ಮೂವಿಂಗ್ ಇನ್ PQRS, ಇಟ್ಸ್ ಮೂವಿಂಗ್ ಇನ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ, ರೈಟ್? ಇಟ್ಸ್ ಮೂವಿಂಗ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಆದರೆ you will be having negative sign, so option 2. I hope you are clear. Okay, The next problem. A refrigerator with the coefficient of performance 1 by 3 releases 200 joules of heat to a hot reservoir. Then the work done on the working substances. So we have the formula beta is equal to Q2 by W, but W can be written as so Q2 divided by Q1 minus Q2 into W, correct? So ಇದು 1 by 3 is equal to Q2 divided by Q1 ಎಷ್ಟು 200 minus Q2 cross multiply ಮಾಡಿದಾಗ minus Q2 is equal to 3Q2. So ಇದು 200 is equal to 4Q2. So Q2 is equal to 200 divided by 4. 50s are right, that is Q. ಈಗ ನನಗೆ W ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಹೇಳಿರೋದು ಅಲ್ವಾ ವರ್ಕ್ ಡನ್. ಸೊ W is equal to Q1 minus Q2. What is your Q1? It is 200 minus 50. It is 150 joules. So option 4. I hope you are clear with that. Okay. So see, in pressure volume diagram, that is PV diagram given below, the isochloric, isothermal, isobaric parts respectively are. So CD, you can take this as at this particular point, CD is nothing but isochloric. Okay, this is isochloric. As you can see, the volume is constant. Okay, so then DA, this is nothing but your isothermal, as temperature is constant. You can compare DA as smaller than DB. ಇದಕ್ಕಿಂತ ಇದು ತುಂಬ ಕಡಿಮೆ ಆಗಿರೋದ್ರಿಂದ this will be your isothermal. Then AB is nothing but isobaric, since the pressure is constant ಆಗಿರೋದ್ರಿಂದ. Okay, so you can say CD, DA and BA option. Okay, so then logically you have to remember the concept based. Okay, as you can see, when a system is taken, from state I to A, state F fall along path IAF. So IAF, they given some Q and W. Path along IBF. So you have the two path here. This is the first one. This is the second one. Okay. So they told you to find then the Q for this particular path. What is the Q for FBI? This is FBI. Okay, FBI ಈ ಪಾತಿಗೆ ಏನು ಅಂತ ಕೇಳಿದ್ದಾರೆ. Okay, as you know that delta Q, right, internal energy is state dependent only, between the two given states I and F, whatever is there at this particular point, this delta U will be same, right? Okay, so I and F hatra delta U will be same. Since if it is same, you can say that IAF hatra U is Q minus W. What is your Q? Q is 50 minus 20. It is 30 joules U. Okay, the internal energy for this loop will be 30. Okay, now FBIK, they've already given it as they've told that W is equal to minus 13 joules. The internal they given as 30 only. We have already found since delta is same for both the cases, so it is minus ulta hogutte. Okay, so again I thought Q is equal to, okay, that Q for IF is 30. Okay, so Q is equal to minus 30 minus 13 adresto minus 43 joules. That will be your answer. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಸೇಮ್ ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ, ಬಟ್ ಆಪೋಸಿಟ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್. ಓಕೆ, ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಯು ಹ್ಯಾವ್ ದ 3 ಥಿಂಗ್ ಅವ್ರು ಹೇಳಿರೋದು. ಒಂದು IIAF, ಇನ್ನೊಂದು IBF, ಇನ್ನೊಂದು ICF. ಓಕೆ, ಔಟ್ ಆಫ್ 3 ಏನು ಅಬ್ಸರ್ವೇಷನ್ ಅಂತ ನೋಡ್ತಾ ಇದ್ದೀವಿ. Heat absorbed in a thermodynamics processes, as you know that the formula delta Q is equal to delta U plus delta W. Correct? Delta W. As delta U depends only on the initial and final state. It is going to only depend on initial and final state, but it is not going to follow any actual path. Therefore, all the 3 paths A, B, C, you can see A, B, C, this all the 3 will be having the internal energy is same. The internal energy is same. Now, you can say work done. Okay, work done that is for IAF ಇದಕ್ಕೆ ಚೆಕ್ ಮಾಡಿದಾಗ you can say it is positive. ನೆಕ್ಸ್ಟ್ ಇದಕ್ಕೆ ಚೆಕ್ ಮಾಡಿದಾಗ ಅಗೇನ್ ಇದಕ್ಕೆ ಚೆಕ್ ಮಾಡಿದಾಗ ಯಾವುದು ICF ಚೆಕ್ ಮಾಡಿದಾಗ ಇಟ್ ಈಸ್ ನೆಗೆಟಿವ್. ಇದು ಕ್ಲಾಕ್ ವೈಸ್, ಇದು ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್. ಸೊ ಫ್ರಮ್ ದಿಸ್ ಯು ಕ್ಯಾನ್ ಸೇ delta Q, correct? So in this case I can say W is equal to delta Q ಆಗಿರೋದ್ರಿಂದ I can say ಇವಾಗ delta Q ಬಂದೇನು, ಇದು ಪಾಸಿಟಿವ್ ಆಗಿದೆ, ಇದು ನೆಗೆಟಿವ್. ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಅಂದ್ರೆ ಯಾವುದಕ್ಕೆ? ಸೊ ಡೆಲ್ಟಾ ಕ್ಯೂ ಆಫ್ ಯಾವುದು IAF is greater than delta Q of IBF. ಅಂದ್ರೆ IAF ಅಂದ್ರೆ 1, IBF ಅಂದ್ರೆ 2. Since the work done, based on work done, you are going to decide your delta. So greater in 1 than in 2. So option 3. Okay. So whatever the diagram we have seen here, the PV diagram of this thing is whatever they given. The work done in the system is ABC. it is given, and the heat is given by 40. So fine. So directly you can use the formula. What is the formula you are going to use it here? The formula, whatever we are going to use it here, is delta U is equal to delta Q minus delta W. So delta Q is 40, or I put together 40 minus 30 is 10 joules. Okay. Next problem ನೋಡಿ. A diatomic gas. Okay, a diatomic gas. You can say for diatomic gas, it is nothing but gamma is equal to 1.4 ಅಂತ ತಗೊಂತೀವಿ. And if the during the process, okay. Okay, so you can say that the thing, whatever the BC, whatever you are going to say, it is adiabatic process ಆಗಿರೋದ್ರಿಂದ the formula will be T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. So T2 by T1 is equal to V1 by V2 gamma minus 1 ಆಗುತ್ತೆ. ಕರೆಕ್ಟಾ? ರೈಟ್. ಸೊ ಈಗ ನನಗೇನು ಬೇಕು? ದ ಎಫಿಷಿಯನ್ಸಿ ಬೇಕು. ಎಫಿಷಿಯನ್ಸಿ ಅಂದರೆ ಫಾರ್ಮುಲಾ ಏನು? ಈಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಮೈನಸ್ T2 ಬೈ T1 ಅಲ್ವಾ? ಬಟ್ ಈಗ T1 ಮೈನಸ್ T2 ಬೈ T1 ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಈಗ ಇಲ್ಲಿ ನೋಡ್ಕೊಂಡು, ಓಕೆ, ವಾಲ್ಯೂಮ್ ಇಸ್ the given volume is V divided by 32V. 1.4 minus 1 VV cancel ಆಯಿತು. ಇಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. It is 1 by 32 whole to the power 0.4. ಸೊ ಈಗ ಇದನ್ನ 1 by 32ನ 2 to the power 5 ಅಂತ ಬರೀಲ. 0.4ನ 4 divided by 10 ಅಂತ ಬರೀತೇನೆ. ಈ 10 2 to the power minus 5 ಮೇಲ್ ಶಿಫ್ಟ್ ಮಾಡ್ಕೊತೀನಿ. 4 divided by 10. So 5 ones are 5 2s are 2 ones are 2 2s are. So the thing will be minus 2 ಆಗುತ್ತಾ? Right? Okay. So ಈಗ ಏನಾಯ್ತು ಇದು? I can write this as T2 by T1 is equal to 1 by 2 to the power 2ನ, ಸೊ ಇದೇನಾಯ್ತು? 1 by 4 ಆಗುತ್ತೆ. ಓಕೆ, ಈಗ ಇಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಿ. You substitute here 1 minus 1 by 4. 4 minus 1 3. So it is 3 by 4 ಅನ್ಕೊಳ್ಳಿ. What is 3 by 4? 0.75 ಆಗುತ್ತೆ. ರೈಟ್? ಚೆಕ್ ಮಾಡಿ. ಐ ಹೋಪ್ ಕ್ಲಿಯರ್ ಆಯ್ತಾ? ಏನೂ ಡೌಟ್ ಇಲ್ಲ? ನೋಡ್ಕೊಳ್ಳಿ ಕ್ಲೀನಾಗಿ. ಓಕೆ, ಮತ್ತೆ ಇದನ್ನು ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. ಡೈ ಅಟಾಮಿಕ್ಗೆ ಗಾಮಾ ವಿಲ್ ಬಿ 0.1. Okay. So the last problem, a Carnot engine whose low temperature reservoir is at 7 degrees Celsius has an efficiency of 50%. It is desired to increase the efficiency to 70%. By how many degrees should the temperature of the high temperature reservoir be increased? Okay. ಈಗ ನೋಡ್ಕೊಳ್ಳಿ, we are going to first ಏನು ಮಾಡಬೇಕು, convert. So they given, so ಈಗ ಫಸ್ಟ್ ನನಗೇನು ಅವ್ರು ಕೊಟ್ಟಿರೋದು ಟೆಂಪರೇಚರ್. ಸೊ ಈಗ ನನಗೆ ಅವ್ರು ಕೊಟ್ಟಿರೋದು T2 is equal to 7 ಡಿಗ್ರಿ ಅಂದರೆ 273 ಪ್ಲಸ್ 280 ಕೆಲ್ವಿನ. So efficiency they given 50%. So formula is efficiency is equal to 1 minus T2 by T1. So 50 divided by 100 is equal to 1 minus 280 divided by T1. So ಅದನ್ನೆಲ್ಲ ಆ ಕಡೆ ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿ ನೋಡಿ. So it is 280 by T1 is equal to 1 minus 50 by 100. So it is 1, 1, 2. So T1 is equal to 280 divided by 1 by 2. So you can write it as T1 is equal to 560 Kelvin. Okay. Next, eta dash is equal to 1 minus T2 divided by T1 dash. So again T2 is to 218. ಆಯ್ತಾ, ಇದೆಷ್ಟು 70 by 100 is equal to 1 minus 280 divided by T1 dash. So find T1 dash again. So it is 280 into 10 divided by 3 ಬರುತ್ತೆ. So it is 933.3 ರೆಕರ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಸೊ ಆಗ delta T is equal to T1 dash is equal, sorry, T1 dash minus T1. So 933.3 minus 560. If you solve, you'll be getting maybe 373.3 Kelvin. So approximately I can take 380 Kelvin. I hope you are clear with this. Do you have any doubt? Check ಮಾಡಿ ಒಂದ್ಸಲ ನೀಟಾಗಿ ಇದನ್ನ. I hope you are clear with that. So this completes the chapter thermodynamics. So in the next class, we'll see with the new topic. Okay. So thank you all. Have a great day.